We are SENSE, Strategic Education through Naval Systems Experiences at Michigan Technological University. Within SENSE, we have multiple different projects going on at the same time. Most of our projects are centered on the Great Lakes or naval applications, however, some are focused on other aspects such as autonomy, machine learning, and the ever-important fun factor. Our robot is an Army autonomous robotics project. This is one of our teams which has a blast doing on it. They focus on using these small little rovers that are able to navigate autonomously and complete various tasks such as full-color depth camera photos or be sent on a LiDAR scanning mission. Here, a rover is seen scanning the 5th floor of the ERC. While all of that is fine and dandy, the real focus of this project is doing penetration testing and patching on the rovers. By various means of hacking, lasers, lights, assorted shiny objects, and other items, the vulnerabilities are being found, documented, and patched over. Our next project is BRAD, or Buoy Retrieval and Deployment. BRAD focuses on the use of a Seaworker 8, a fully autonomous 7-meter-long sailing vessel, to autonomously deploy and retrieve spotter buoys using a custom claw and arm that they are designing. Through the manufacturing process, various pieces were created, tested, and modified to operate properly. These challenges were then brought to the enterprise and explained and approved and then implemented finally. After being approved, the changes are then implemented into the design of the arm, claw, and mount system, and the whole process repeats itself until we have a fully designed system. Once all of the changes are implemented, we have the fully assembled piece for our final product of the project, which we are also working on the electrical system and components for. All the components are required to be waterproof, which adds a little bit of a challenge to it as well. Our third project we have is MECC, which is the Marine Energy Collegiate Competition. MECC focuses on creating either a device that generates blue energy or a device that protects the shoreline. Another focus of MECC is community outreach. Members of the team will go out to different schools and organizations to talk with them about their projects and do some demonstrations, as seen here. Last year, MECC built, tested, and presented an oscillating water column generator. This year, MECC is building a device for shallower waters which will protect the shoreline as well as generate blue energy. Another project we have had for a few years now is FORD-ME-FASO, which stands for Making Experiences with Forward Acoustic Sensor Odysseys. FORD-ME-FASO is a project that uses an array of microphones, as seen here, to run sound and record it, and then run it through an AI that uses the slight differences between the different channels on the recording and an algorithm to determine what the sound is and where the sound is coming from. One of the biggest challenges is getting the right type of data to be able to train the AI to recognize these differences between similar sounding sounds. One of the ones we have had issues with is the confusion of an engine and a power drill. SASI, or Sinkhole Aquatic Sampling Instrument, is a brand new project that we received this year. The goal for SASI is to create a device that can go onto a remotely operated underwater vehicle that is able to collect and sample of a microbial mat. While this task may sound simple, the issue arises when you learn that the microbial mat is extremely fragile. On top of that, the mat forms in sinkholes in Lake Huron, where the two sources of ground and lake water mix. The current method of collecting samples requires sending divers down to collect the samples manually. This is both expensive and inefficient with time. Due to the lack of sample substitutes, materials are required for testing. One of the materials that we were recommended was bentonite clay, which is loaded into a fish tank for testing, as seen here. The final design itself is fairly simple. A waterproof linear actuator, a few butterfly valves, a couple of pieces of pipe make up the final design. Throughout the project, team members got to enhance their skills in electrical construction, 3D printing, assembly, and testing environment setup. Seen here is a test in action. Both butterfly valves start open as the actuator is slowly advanced forward. Once the actuator is fully advanced, the frontmost butterfly valve closes, trapping part of the sample inside. After the sample is trapped inside completely by the second butterfly valve, closing the linear actuator can retract. Seen here is a failed test as the bentonite clay was disturbed too much. The action of the device itself can be seen more clearly close up. Our final and newest project is SWAB, which is Surface Water Aquatic Bugs. This project focuses on the use of water strider and surface tension mechanics to create an autonomous bug that has assorted AI swarming capabilities. Thank you for watching. If you have any questions, please visit our website, sense.mtu.edu.